volumes. Okay, good morning class. So at this point we're looking at measurement. You guys had some homework, correct? Right, the homework was exercise 8.3. Right. So exercise 8.3 was on page 266. Hey, welcome. So it says determine the determine the volume and the surface area of the object shown in the diagram. Assume that all the objects are mathematically shapes for this purpose. Okay, which means to say, we look at this here, there isn't this overlap here basically, that's what we're trying to say. Okay? Don't forget you're writing on the 1st of November, no? On those two topics. On these two topics, which is your volume, your measurement and analytical geometry. Right, so how do we determine the volume, people? Volume is going to be area of base times height plus twice area of base. The shape of this base is a composite shape made up of a rectangle and a square. A rectangle and a triangle. Not so. So to calculate the volume is area of base, so area of a triangle plus the area of the rectangle times the depth of the object. So how do you calculate the area of a triangle? So half a base times height. The base here is going to be 3, so it's half. 3 times the perpendicular height. So this length here. So this whole length is 1.8. And this length is 0.8. Then this length will be 1. You all agree with that? So we have a perpendicular height there of 1 plus the area of this rectangle, length times breadth, so 0.3 times 3 times the depth of this object, which is 4. Okay. So that would be open brackets, a half times 3 times 1 plus 0.8 times 3 times 4. That gives you 15.6, is that correct? So it's 15.6 meters square. Sorry. We look at the total surface area. So it will be perimeter of base times height, so it's the perimeter of the triangle times height, plus twice area of base. So it's 2 area of base, which is going to be the area of the triangle, plus the area of the rectangle. So that part we have already. However, the perimeter is going to be that length plus 0.8 plus 3 plus 0.8 plus that length. Well, looking at that triangle, I don't have those lengths, not so. So I'm going to redraw that triangle here. We have a perpendicular height of 1. What is this length here? 3. So from there to there is 1.5. So we have a triangle, a right angle triangle, that being 1.5, and I can calculate the slanted height, or the hypotenuse on the triangle rather. Not so? So you're going to say hypotenuse squared is equal to 1.5 squared plus 1 squared. So hypotenuse works out to be the square root of 1.5 squared plus 1 squared. Gives you root 13 over 2. Okay? So that's going to be root 13 over 2. Okay, so if you work out that perimeter, it's going to be root 13 over 2 times 2. There's that one and that one. Not so? Plus this length and that length. So 0,8 times 2 plus this length, which is 3, times the depth of this object, which is 4, plus 2 times the area of this base. I can take from there, which is going to be a half times 3 times 1 plus 0.8 times 3. Okay. That my calculator. Open brackets. And answer times 2 plus 0.8 times 2 plus 3 times the depth of the object, which is 4, plus 2 open brackets 0.5, which is half, times 3 times 1 plus 0.8 times 3. 40,42, is that correct? Meters. Correct? Yes? Yes? 40,62. Yeah. Any confusion here? I made a mistake here. I said perimeter of the triangle is actually perimeter of the base. Okay, which is made up of that triangle and those 3 sides of the rectangle. Okay. Okay. Let's look at B. So what we have here is, looks like a cylindrical shape is cut out of this block. It looks like it, no? Am I right? No? So wooden block. Oh, it's a block basically, and the what's the name? A cylindrical shape is bored through the, cut through it. Okay. So, looking at this here, we're looking at the volume. So it's going to be the volume of the rectangle minus the volume of the cylinder. The angular base minus the volume of the cylinder. Not so. So how do you calculate the volume of this right prism? Is the area of base times height. So what type of shape is this base? A rectangular base. So it's going to be length times breadth. So it's going to be 7 times 12 times 10 minus the cylinder is going to be, the area of the cylinder is pi squared times height. So it will be pi r. Now here we have a problem. Sorry? Where? This here? Yes. Is it at the bottom? The hard copy, okay, no problem. So that is 2 centimeters then. Not so. So what's the radius here? 1. So it's pi squared times height, which is again 10. Okay. So that, yes?
So, also there's another way. Do you like sheet to include the radius for the cylinder because the cube already includes the radius of the
In number this part here. But you must remember we assuming that this is cut out. So the volume is basically what is left after that is cut out. Understand? So you're not saying leave the cylinder.
No, so the radius of the cylinder is already included in the cube.
You see, the volume of what we're calculating is the volume after the cylinder is taken out. So we actually work in the volume of this here. You understand? That is what I'm calculating. The volume that is left after the cylinder is taken out, or cut out. So if you are saying that the radius is already accounted for when we've calculated the volume of the first part, that means you say I'm calculating then the volume of a solid block. You understand? They had to specify it here, because not everybody's going to see it like that. Okay. So that simply works out to be 7 times 12 times 10 minus 5 times 1 squared times 10. Gives you 808, 58 centimeters cubed. What's the answer they have?
It's that also.
Is this it? Okay.
Yeah.
So that's basically what they did, what they meant. Okay. Let's look at the total surface area. It's going to be perimeter of base. Now you see that this base is going to be a square, a rectangular base, which is length times breadth. Okay. Perimeter of base, which is going to be 2 times 7 plus 2 times 12. Now that would have given you the perimeter of a normal rectangle. Not so? Then the perimeter of that must be added. Okay, so what you do is you say 2 times 7, which accounted for that there, and 2 times 12, which accounted for those two, plus the circumference of the circle accounted for that there. Can you all see that? And how do you calculate circumference of a circle? 2 pi r. Okay? And your radius is of course 1 times the depth of the object, which is 10. That's your perimeter of base times height. Plus twice area of base. Now if you look at this base here, the area of this is going to be length times breadth, which is 7 times 12. But the circle is cut out of it. So I must minus the area of a circle, which is pi r squared. Okay. Let's see how far for we. Open brackets. 2 times 7 plus 2 times 12 plus 2 pi. Close brackets times 10 plus twice area of base is 2 open brackets. 7 times 12. 7 times 12 minus pi. 604, comma 55 centimeters. What do they have?
That.
Okay. Who else got that answer? Very nice. C. We're looking at C. Here we can see we have a capsule, no? So what are our shapes here? There's cylindrical shape, not so? And 2 hemispheres, which makes a 1 sphere. Not so? That's what I see. So if I cut this here, and then you got your 2 hemispheres. So the volume is going to be a sphere plus your cylinder, your cylindrical shape. Also, how do you calculate the volume of a sphere? 4 4 over 3 power cube plus area of a cylinder, area of base times height, is power square times the depth of the object. So it's 4 over 3 pi. What's the radius? If that is 0.75, the radius is half of that. So it's going to be 0.375. Okay? 0.375 cubed plus pi, the radius 0.375 square times the depth of the object. Remember now that from here to there.
I also thought that, but then they just use 1.5 centimeters for some reason as the height.
And they are wrong. Or the diagram is wrong. Because according to this, you can see straight that this is inclusive of that thing. Not so? So I would take it off. So it's the depth of the object, which is 1.5 minus 0.75 times 2. Why? Because that is going to be 0.75. No. Not times 2. Just 0.75. Why? Because that and that is going to be 0.75. 0.375, sorry. No? For both sides, it's going to be 0.75. Let's put that in the calculator. Shucks, what's going on here? Walaikum salam. Alhamdulillah. Okay, so that's going to give you 4 over 3 pi times 0.375 square cube plus pi times 0.375 squared times open brackets 1.5 minus 0.7. I get 0.552. No? But you see the answer is different. Yes, Michael? So according to the hard copy, this is actually here. Okay? If it is like that, so if you had gone with the whole length, then this is the answer you should have gotten. Eh? But since they changed it, so it's times 1.5, no? Is that correct? Alright. So just delete that. Gives us 0.88, is that correct? Okay. Again, it depends on how you see the diagram, okay? But clearly they made a mistake and then they corrected it in the next version of the book, okay? Yes, Michael?
So,
Yes.
what if I don't know why, but then I knew that everything was always the hemispheres thing, but then I didn't think of making it like a full circle.
So if you're going to say the half of a sphere plus a half of a sphere and you work it out, it will still give you the right answer. It should give you the right answer. Okay, I can have a look at it when we're done. Otherwise you're going to spend a lot of time there. Huh? So let's go with the total surface area. How do we calculate total surface area? It's going to be the surface area of the sphere plus of the cylinder excluding the areas of the base, twice area of the base. Why? Because the two hemispheres is connected there. Not so. So how do we calculate the total surface area of a sphere? 4 pi squared. Not so. Is that the area, the area of the sphere?
Yes, sir.
Yes, okay. Plus perimeter of the base, which is 2 pi r, times the depth of the object, plus twice area of base, which we're not going to consider because of that being the base. Okay, so it's going to be 4 pi. My radius is 0,375 squared plus 2 pi r 0,375 times the height of the object, which is, we're going with the change there, which is 1.5. So let's put that in the calculator. So it's 4 pi times 0,375 squared plus 2 pi times 0,375 times 1.5. If we 27 over 16 pi, which is 5,30. Is that correct? 30 centimeters squared. What do you have, Michael? Yes? Read this line out for me that you have. The second line.
Okay, so I have, what line is that?
Okay, you read your first line.
Oh, okay, so I have 2 pi r h
So you got 2 pi r h, yes?
plus 2 open bracket 4 pi r squared over 2.
Huh? Is that it? Then you should get the same answer. So this cancels and it gives you exactly this here. What was your radius? Check your radius.
0.375.
Times height.
0.75.
Now you see, now this here is actually the height of the cylinder. So how can you have 0,75?
Because no, sir, the thing is I'm using
The whole length being 1.5.
yeah.
Yeah, okay, no. Just change it and then you see. If you still don't get the answer that they have, then you can discuss it, okay? But you're on the right track. 100%, okay? Okay, that. So I'm going to go camping now. So what do we have here? We have the volume. What type of shapes do we have here? We got the cylinder. That's the cone, the conical shape there. So remember they told us we were going to use pure mathematics here without considering that overlapping and all of those. Okay. So the volume of a cylinder, pi squared times height, plus the area of a cone, a third, area of base times perpendicular height. That's all. So it's going to be pi, the radius, it's going to be 3 for both, squared times the height of the cylinder, which is 2 plus a third. The area of the base going to be pi r squared, so it's pi times 3 squared times the height of the cone, which is 2.5. So that's going to give us pi times 3 squared times 2 plus 1 over 3 times pi times 3 squared, which is 9, times 2.5. 51 over 2 pi, which is 80,11. Is that correct?
Yes.
80,11 meters cubed. Now we're looking at the surface area. Now the surface area is going to be a cylinder. However, the top is not going to be considered. Can you see that? The top is not going to be considered of that cylinder. Why? So it's connected to the top of the cone. The bottom of the cone, the base of the cone. Plus that conical shape, excluding again that base there. Okay. So what is the area, the surface area of a right prism? Is perimeter of base, which is 2 pi r times height plus twice area of base. But in this case, we're only going to have one base. So it's plus area of base, which is pi r squared. So that is for the cylinder. For the cone, how do you calculate the area of a cone? It's pi rs, which is your slanted height, plus the area of that base, which is pi r squared. But I'm not going to consider that. Why? Because it's connected. So it's not on the outside, not the external or the surface area. It does not form part of that thing. So what I need to do is I need to work out the slanted height there, which is this length here. Okay? Look at that, the right angle triangle. This length is going to be 3, of course, and the height is 2.5. So how do we get the slanted height? Slanted height is going to be the square root of 3 squared plus 2.5 squared. You could have put that in the formula there as well if you want. There will be no blame on you, okay? So the square root of 9 plus 2.5 squared. Okay? Give 61 over, root 61 over 2. So that's going to give you 2 pi r, which is 3, times the height, which is 2, plus pi times 3 squared, plus pi times 3 times, what was that? The root 61 over 2, no? The root 61 over 2. So we go 2 pi times 3 times 2 plus pi times 3 squared plus pi times 3 times answer here. It gives you 102,78. Is that correct? Meters squared. Is that correct, people? Anybody made a mistake? They want to talk about it? Or don't, you girls of those type, they want to talk about the mistakes? Okay. That was D. Let's carry on with our lives. Number 2. If a cone and a sphere has the same volume and the same radius, calculate the height of the cone in terms of r, the radius. If a cone and a sphere has the same volume. Okay. So where do we start? We started by setting up an equation. Okay? We say that the volume of the cone is equal to the volume of the sphere. Okay. Well, how do you calculate the volume of a cone? This is a conical shape now. No? The volume of a cone, third, A, H, not so, equals area of a sphere, 4 over 3 pi r cube. Okay. So the area of the base is going to be a third pi r squared times the height of the object. Okay. So remember, what did they say here? Calculate the height of the cone in terms of r. So we must, in other words, make h the subject of the formula. Okay? So what I do is I divide both sides by a third pi r squared. So it's a third pi r squared. So that now gives us h on the one side is equal to, Now a 4 over 3 times a third is going to give you 4. Okay? The pi's cancel. R cubed over R squared is R. So H is equal to 4R. Okay? It's a nice question. Let's look at the next one. We are told that if 3 standard tennis balls, as you can see on the side here, if 3 standard tennis balls of diameter 66 millimeters can be packed in a can. Calculate the volume and the surface area of the can. Allow 2 millimeter spaces around the outside of the ball for some movement, but no space between them vertically. Note that the base of the can is half a sphere. Jesus. Alright, let's go. So, the diameter of the ball is 66. So there is 66. 66. 66. Which gives me a radius of the balls at 33. Not so. Then the 2 millimeters on top and 2 at the bottom. Okay. So from this one point to that point, inclusive of that 2 millimeters, it's going to be 66 times 3, which is the 3 balls, plus 2 times 2, which is the 2 millimeter spacing above and below. Not so. So that's going to give us 202. Okay, 202 millimeters. Okay. What's it called? Calculate the volume and the surface area. Okay. Then we are told that we have 2 hemispheres, which means to say there's a sphere here and there's a sphere here, as you can see in the diagram. Okay. Now, yes? Yes, yes. The 3 standard tennis balls of diameter 66 can be packed in the can. Calculate the volume and the surface area of the can. Allow 2 millimeter spaces around the outside of the ball for some movement, but no space between them. That's why I haven't counted any space between them. Note that the base of the can is a half a sphere.
Like the in is
Yeah, it goes inside. It doesn't come out. Does it come out? Not in. Okay. Then that's one. So that's going out. You guys must play tennis. No, I don't play tennis. I always think the thing came out. So glad you guys know what's going on. So that's what I'm supposed to see.
only at the bottom.
Only at the bottom.
The top is a cylinder and then all the stay at the bottom. Then back the base of the can is like just the in just the can.
So it's only the one in.
Yes.
Okay. Okay, I'm learning something. Because Osmos again, others were a can of this thing. Is it on? So it's this side, no?
Yes.
Okay. Right. So this is like your cylinder here. Your circular base. Right. Now it makes sense. Alright. So then my height remains at 202 for the whole thing. Alright, okay. So I was not going to work out a different height for the can. Because if I'm going to see that the hemispheres is coming in, then the height of the can would have been longer. Okay, than what I have had. But if this is the case, then the height of the can is at 202, to my understanding. Okay. Yes. What else am I missing?
So when they say that the 2 millimeters around, so
Yeah, I'm still getting to that. Because now, this is the radius of the ball. Now, but from there to there, the what's the name of the can is going to be, this is a 66 plus 2 on either end, which is 70. Is that correct? So that is 70 millimeters across on the can. No? That's what you wanted to say? Yeah, okay. I was getting there. Right, so let's look at the volume. The volume of the can is going to be area base power squared times height, which is pi. My radius of the can is going to be 30, 35, 66, 33. Yeah, 35. Okay? Go half of 70. So it's 35 squared times the height of the can, which is 202. Right, say yes.
So then the full height of the can is 30, right?
Yes?
Because if you think about it, then the holes, or all the holes going to be in the plates, like all of the silver one. You know what I mean? So then that means that you're going to have to minus, put in minus the holes to get the actual height.
Because of the scale.
Yeah.
Because remember.
Okay, so this here will give that till this being your what's the name? No?
Okay, so from the end point of from the end point line, like here, the bottom of the,
Yes?
all the way to the top, there's 280.
Yes?
But then, half one bowl is going to take up space in the bottom,
Within this
Yeah.
hemisphere, yes?
Yes. So that means that we have to minus the radius to get to the cylinder side. I do.
Yes, it's right, you're right. So I must take off that length, which is 35. Okay, so the height of the cylinder is going to be 202 minus 35. Is that what you're saying? Right. Plus the volume of the hemisphere. Huh? Yes, just hang on, we just get it right first. Oh. So that is of that, as you can see, it was marked there, plus the volume of the hemisphere, which is 2 over 3 pi r cubed. No? Is that correct? 2 over 3 pi, your radius is going to be 35 cubed. So 35 squared times 202 minus 35 plus 2 over 3 pi times 35 squared cubed. Is that correct?
So,
Yes?
what I converted the millimeters to centimeters.
So they wanted it in centimeters.
Yes. They didn't clarify for some reason.
Okay, no problem. So we know that 1 millimeter is equal to, 10 millimeters. 10 millimeters is equal to 1 centimeter. So it's cubed. So it's going to be 1,000 millimeters cubed is equal to 1 centimeter cube. So if I divide that by 1,000, gives you 294. Is that correct? Still not. Okay. So where am I going wrong? You got the right answer, no?
Yes.
Yes, okay. We are counting that 2 millimeters twice here. We're counting it here and we're counting it here. So one of the two must be taken off. There are 2 millimeters. Yes, Michael? Your hand is up. Not up, okay. Let me just wait. Let me just take this 2 off here.
So you didn't include the 5.
Sorry?
You didn't include the 5 at the beginning.
The 5.
5.
5. Oh, that's 5.
Yes.
What's wrong with me? Many things, no? Alright, let's check now. Is that correct? 732. Alright, so let's just check again. So what we have is 3 salad tennis balls of a diameter of 66 millimeters is packed in the can. Calculate the volume and the surface area of the can. Allow a 2 millimeter space around the outside of the ball for some movement, but no space between them vertically. And you are told note that the base of the can is half a sphere. Okay. So what we said was, if that diameter is 66, then each ball will then be 66. The length will be 66. Okay? So the area of the cylinder plus the hemisphere, as you can see, the cylinder plus this hemisphere, the area is going to be pi r squared, which is perimeter area of base times height, which is pi r squared times height, plus your hemisphere, which is 4 over 3 pi r cubed, divided by 2, which is 2 over 3 pi r cubed. Okay? So what we needed to find was the radius of the cylinder times the height of the cylinder. Okay? So the radius of the cylinder, okay, the radius of the balls is going to be 33. Plus a 2 centimeters allowance there, it's going to give you 35. Okay? So it's going to be pi times 35 squared times the height of the cylinder. So the height of the cylinder, we said it's going to be 202. Alright? Now, this whole length here is actually 202. Minus this, remember this is a hemisphere, so half the ball is going to go into that. Okay? Which is 35. It's firstly 33 radius, but the 2 millimeter splay there is going to give you 35. Okay? So, with this length here is going to be 202 minus 35, which is going to give me then the height of the cylinder. Okay? Plus the area of the volume of the hemisphere, which is 2 over 3 pi times the radius, which is 35 cubed. Okay? Let's look at the total surface area. So let me just write this down here. The answer is 732, comma, 49 millimeters. We converted it, no? Centimeters. Okay. Otherwise, if you times by 1,000, you get the millimeter cube solution. Okay. Then for the total surface area, okay, so we got for the total surface area, we got your cylinder, excluding that base, plus a hemisphere, excluding its base. Okay? So how do you calculate the area, the total surface area for a cylinder? Perimeter of base times height, so it's 2 pi r times height, plus twice area of base, but I'm only going to account for one of it. So the other one I'm not considering is pi r squared, plus the area of a sphere is 4 pi r squared, the hemisphere is half of that, so it's going to be 2 pi r squared, normally plus pi r squared. But I'm not going to consider that because why, that is not exposed. So we're going to say 2 pi, your radius is going to be 35 times the height of the cylinder, it's going to be 202 minus 35. Huh?
Exactly.
Okay. You just want to tell me I'm on the right track, thank you. Plus pi, the radius is going to be 35 squared plus 2 pi, and your radius is going to be 35 squared. So that is going to be 2 pi times 35 times open brackets 202 minus 35 plus pi times 35 squared plus pi 2 pi times 35 squared. That's correct. Okay. Divided by 1,000. You get it in centimeters. No, not 1,000. 100. Because now, if you want your answer in centimeters square, then 10 millimeters is equal to 1 centimeter squared. It's going to be 100 millimeters square is equal to 1 centimeter square. So now you divide that by 100, gives me 482, comma 7 centimeters. Yo. That was a rough one, huh? I think now we need a break. So now changing the dimensions. Okay. So we are reading on page. See, some of you are very good at this. Right. So which page are we reading from? Example on page 267. Okay, this is a revision of work that you did in grade 10 on scaling objects. If shapes or objects are scaled, similar shapes and objects that has exactly the same proportion as the original but different sizes result. Okay. If a 2D object is scaled by a factor of k, then a similar shape is created. This shape has all its dimensions as a ratio of k to the original object. The ratio of the corresponding areas is k squared. If an object is scaled by a factor of k, then the volume of the object will be scaled by a factor of k cubed. Or if the dimensions of two objects are scaled in the same ratio k, then the ratio would be k cubed. Okay. Note that k can be a whole number or a fraction. It can't be negative numbers, as the measurements cannot take on negative values. Okay. So basically what they're referring to there is, if you got, I know you guys didn't do this last year, but what they're speaking about here is that if you got, for argument's sake, a rectangle, this says a 2 by 3 rectangle. The area of this rectangle is 2 times 3, which is 6. Not so. Now the k factor, if you enlarge this by the same k factor, let's say we're doubling both sides. Okay? Then we have, so here your k factor is 2. No? Then the triangle now would be a 4 by 6 rectangle. Not so. And the area of a 4 by 6 is going to be 24. Not so. Now if you go and say, okay, what if you go with a k factor of 3? K factor of 3. So you say 2 times 3. 2 times 3 is 6. And 3 times 3 is 9. Which gives me then an area of 9 times 6, which is 54. Not so. Let's go with a k factor of 4. This would now be what? 2 by 4, which is 8. 3 by 4 is 12. So area is going to be 8 times 12. What's 8 times 12? 96 centimeter unit square. But what you notice is that when you have K, what would 24 divided by 6 be? 4. Not so. So 24 divided by 6 is 4, which is the same as 2 squared. Not so. If you say here, what is 54 divided by 6? 9, which is the same as 3 squared. Can you see that? K squared. K squared. What if you add 96 divided by 6? 16, which is the same as 4 squared. Can you see that? So in other words, if you are enlarging a shape by 2 dimensions by the same K factor, then it will be K squared. So if I do the same for volume, what you notice? It will simply be K cubed. Okay. So you guys can write this note down. I'm going to pause the video at this point. Alright, so at this point we're looking at the example, and this is the example on page 3268. Okay. Alright, so here we are told that this person has a model of a rondable and wants to increase it by a scale factor of 3. Calculate the surface area and the volume of the original and the new model. Okay, so if you're going to look at this shape here, okay, have we done this calculation already? Is it the same dimensions? No, okay. So if you're looking at the volume is simply going to be, so what we do is we first work out the normal volume. Okay, the volume is going to be the area of the cylinder, which is pi squared times height, plus the area of the cone, which is a third area of base, which is pi squared times the depth of the cone. So it's going to be pi. Your radius is going to be 2.5. As you can see, this is 5. So it's 2.5 squared times the height. Yes? Oh, it has its own. Okay. So it's a bit different to the shape that we worked with before. So that's going to be 2 squared times, so 4. 4 times the height of the thing, which is 6. Plus a third pi. What's the radius? 5. Will it be 5 squared times the height of the cone, which is 3. So that gives us 5 times 4 squared times 6 plus a third times pi times 5 squared times 3 is 121 pi, which is 380, 13. Yes? The radius of the cylinder is 5. Okay, but the hard copy is 5, then you just use 5. But you get the idea. You don't get the idea. Oh, you get it now? Who said no? Oh, yeah. Okay. So that is going to be centimeters cubed. Now, if it is by a scale factor of 3, then the new volume, this is the original. Now, the new volume would simply be 380,13 times 3 cubed. Can you see that? So that's simply going to give us that answer multiplied by 3 cubed. It's going to give you 10,263, 58 centimeters cubed. Can you see that? Yes. Volume is 3 dimensions. Yeah. Now if we had worked out the total surface area, you go through the same scenario, same notion. Then you multiply it by k squared, which is 3 squared. Okay. For homework, I would like you guys to do exercise 8.4. Okay, for some reason or other, I didn't cut number 1 and 2, but I'll do it tomorrow, okay? People, enjoy the rest of your day. Good morning, class. Yes? Yeah, just to see. You see here, this, you let k store here. So there's 3 things equal to k. So it's going to be k minus 6 minus 27 over k is equal to 0. Now you multiply by k. So it's k squared minus 6k minus 27 is equal to 0. Can you see? Now, pleasure. Yeah, if you go with the 3x first, then it's going to be 3 to the 2x minus 6 times 3 to the 2x and 6 times 3 to the x minus 27 is equal to 0. Now that brings us, then we say let k equals 3 to the 2x. So that's going to be k squared minus 6k minus 27 is equal to 0. Which brings you the same.